Hi, hello. This is Gates Engineering Institute. Once again, we are known to carry out sophisticated structural engineering analysis and design, conduct trainings to various specific code of practice, and address the most stringent questions that are put forward to us by many of our listeners and observers. We got this question from one of our consultants who was designing a structure, and the client is requesting that, so he designed the structure to the specified Eurocode of practice. This is a structural steel frame structure, and the structure was designed to the Eurocode of practice, so Eurocode 311 and EN 1990 and EN 1991-14. Now, the structure was designed to the ultimate limit state, so it's a limit state design criteria where you analyze the structure and subject the structure to the various design conditions: the persistent design condition or design situation, the accidental design situation, the transient design situation, and all the corresponding load combinations associated with the design conditions are applied to the structure. However, at serviceability limit states, the code specifies that you would have to investigate the structure against the deflection limitations that are covered by the EN 1990. Now, the code was very clear and it specifies in clause 7.22 that horizontal deflections are analyzed in line with the description captured in Annex A14 of EN 1990. We need to pay very close attention to this. It specifies that horizontal deflection are analyzed in alliance or in compliance with the requirements specifically described in Annex A14 of EN 1990. However, the limits for horizontal deflection under the specified combination, so we have the characteristic combination, we have the constitutive combination, and so on. The limits of deflection is captured under the specified combination in the national annex. So the national annex will specify the limits of combination. Now, okay, so the code specifies the different combinations to be taken into consideration in the determination of the serviceability limit states. It specifies the characteristic combination, the frequent combination. It also specifies the quasi-permanent combination, and for each combination, the characteristic or representative values of the variable actions are specified clearly in the mathematical expression that represents the combination to be catered for in the design of the structure. Now, this individual reached out to us and specified that his client is asking that the drift command instead should be used in the evaluation of horizontal deflection. Now, this is wrong, and we're going to explain why this requirement or this request by the client is wrong. Possibly the client does not understand the application of the drift command instead. So we are going to use an example to explain the drift command and how it applies in the calculation of deflection instead, and if what this client is requesting for is accurate and complies with the requirements of the EN 1990. Okay, so let me use this. This is an arbitrary portal frame structure. That's about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 meters. So this is about a 20 bay portal frame structure. So this is a different portal frame structure supplied by a separate client. I want to use the drift command to explain how it works instead. So what does drift command actually imply? Does the drift command satisfy the requirements of EN 1990 when it comes to the evaluation of horizontal deflection? First of all, let's look at what EN 1990 says when carrying out horizontal deflection evaluation or assessment. Now, in clause A143, it specifies that vertical and lateral deflection should be calculated in accordance with EN 1992 to EN 1999. So these codes, these sections of the Eurocode should be referred to when you want to investigate for vertical and lateral deflection. Pay very close attention to this. It says that you need to use the appropriate combination of action according to expression 6.14a to 6.16b. These are expressions that I just spoke about prior to now, that talks about the type of combination, whether quasi-permanent combination or characteristic combination, as the case implies. The corresponding Eurocode will tell you the combination to make reference to when you're evaluating the deflection limit. Now, it now specifies that vertical deflection should be evaluated using the schematic shown in A1, but our concern is lateral deflection. Now, it says lateral deflection is evaluated in line with the schematic represented in figure A12. Now, figure A12 shows that you would have to check, depending on the code required, the specific reference EN code requirements, you have to check the lateral deflection of the top of the node with reference to the bottom of the portal frame. Okay, so this is the entire story deflection evaluation. Then you have to check the subsequent story lateral deflection evaluation, that the relative deflection between successive story falls within the limitation. Now, if this client is requesting this consultant to use, so he has checked the deflection in line with the code, and the client is asking him to use start story drift command to evaluate deflection. Now, he is not used to the story drift command, and he is in bedlam as to how to go about responding to the client. So I want to put forward this explanation for the benefit of all participants on what the story drift command is, and if it applies to the requirements of the Eurocode specifically in the determination of the lateral deflection limits in compliance with the specific combination values. Now, I'm going to use this as an example. So this is a portal frame structure. So it has been analyzed. If you go to post processor, I have specified the lateral drift factor at 0.5. So what it means is that if the code specifies a deflection limit of, say, the deflection exceed L over 20. So 1 over 20 becomes your lateral drift factor. 1 over 20 becomes the lateral drift factor. So for the purpose of this explanation, I am assuming that the deflection limitation should not exceed half the vertical height. Okay, so my lateral drift factor eventually evaluates to half, which is 0.5. I want to explain what lateral drift factor does. So I have provided a comment that specifies print story drift factor, and then let me run the analysis. Alright, so the analysis is completed. If you go to the post processor, and let's look at what this lateral story drift factor does. Let's look at it correctly and see if the client requests corresponds with the code requirements, or if the client is wrong in its request. Now, what the lateral drift factor is that what it does is that it will subdivide your structure into horizontal arbitrary planes that corresponds to the location of each joint. Let me explain this a little bit further. This joint is at y is equal to 0. This is at y is equal to 6. This is at 6.345, 6.69, 7.034, and so on. So at every joint, it subdivides your structure into arbitrary horizontal planes. In this case, I will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. About 11 planes. That's as if I did not miss out any other horizontal joints. Okay. Now you can see 11. You can see. So it has subdivided the structure into 11 planes. Now, if I want to determine the horizontal deflection in line with the Eurocode, what I would do is to check the horizontal deflection of the entire nodes that make up this portal frame from here to here. Along these nodes, check the maximum horizontal deflection and then the horizontal deflection at the base and get the difference between that. That gives me the horizontal deflection, and then divide it by the height and check if it confirms with the limits. But is that what story drift does? No, story drift does not do this. What story drift does is that it gets the average deflection of the entire nodes that occur at a certain plane. It gets the average deflection of the entire nodes that occurs at a certain plane. When it gets the average deflection in the X, Y, and Z, it gets the relative deflection relative to the subsequent nodes. Let me explain what I'm saying. So if I take this as an example, okay, let's look at this as an example. This is at elevation 6. Let's go back to the post processor. Now this is at elevation 6. Let's use elevation 6 to explain. Now at elevation 6, the horizontal displacement is shown here as 7.2715. What is this 7.2715? Now the drift is shown also at 7.2715. So I need to explain this. What this thing does is that, now look at the entire nodes at this elevation, at elevation 6. You have all these nodes. Now let's go to the post processor. This is displacement. So this is displacement of all the nodes. Let me copy out the displacement. Let me copy out the displacement of all these nodes selected. Okay. Alright, so this displacement of all the nodes. This is the X displacement. This should be the Y displacement. Let me just check. Okay, so this is the X displacement, that's the Y displacement, and then this is the Z displacement. I'm trying to explain what story drift does, and if the request is in line with the code. Now, let me get the average of all the X deflection. Okay, so this is the average of all the X deflection. Okay. And then let's look at the average of all the Y and Z deflections. Okay, so the average of the Z deflections is approximately 0. This 10 from minus 19 is about 0. This is about 0.177 millimeters. All these are in millimeters. Please take notes. Okay, so these are in millimeters. So if you put that in cm, that's about 0.017. So, but let me start with the X deflection. This is the average deflection of all the nodes in the X direction, 72.71. So let's go back to what is reported. Can you see? So average displacement is 72.715 millimeters. Drifts, what it evaluates as the drift is the relative displacement of this relative to the subsequent or the previous nodes. So this minus this gives you 7.215. And then it checks if this is in compliance with your limitation. Remember, I specified a drift factor of 0.5. So it checks if this value 7.215 is more than half the length. So it has provided the factor. The factor is L over 82. How did it get L over 82? Alright, so let's see how it obtained L over 82. Right? Now, let's come back here. Now, so I specified a drift factor of L over 2, right? Now, L over 2 was what I specified as the drift limitation. And the calculation of the drift from start analysis is 7.2715 millimeters, cm rather, which is 0.07215. Okay, so this is equal to L over a drift factor, which I represent as Dirac. Okay, so Dirac then becomes L over 0.07215. Right? Now, L itself is the height. Okay, the height at that location between the successive arbitrary horizontal planes. So in this case, it is 6 meters. So if I do 6 over 0.07215, that will give me 6 divided by 0.07215. That gives me about 83. Okay, it's 0.072715. So if you do 6 divided by 0.072715, right, that gives me 82.5. So that is how it arrived at 82 points, 82 arbitrary. So what drift calculates is not in compliance with the code of practice. So I have responded to the consultant that he needs to write back to the client and address these key points. That drift command is not used in calculating the horizontal deflection. Let's look at what the code specifies. Now, the UK National Annex specifies that the following table gives suggested limit for the calculated horizontal deflection under the characteristic load combination due to variable actions alone. Now, it says that in each story of a building with more than one story, so this refers you back to EN 1990. So this is telling you this, with more than one story, in each story of a building with more than one story. So what it says is the deflection limitation should be height of that story divided by 300. So the deflection limitation should be height of the story divided by, so this deflection limit is h over 300. So h over 3. So what should be done typically? What should be done is to get the deflection, the maximum deflection throughout the entire load. Check where it is, right? And then when you get that deflection, get the height of the structure, height over 300, and check if it falls within the code's limits. Thank you very much for listening, and follow us and like this page for more detailed theoretical explanation of chaotic issues in structural engineering.